Okay, in this session we're going to be having a look at Unit 4, Chapter 4, Trigonometry in a Unit Circle. We're looking at trigonometric ratios, Part 2. We're looking at non-special angles of rotation and quadrantal angles. We're going to be focusing on determining approximate values for non-special angles for trigonometric ratios and determining values of quadrantal angles for trigonometric ratios. I want you to recall your primary trig ratios are sine, cosine, and tan. Tan, of course, is sine over cosine. Recall your reciprocal trig ratios are cosecant, which is the reciprocal of sine, secant, which is the reciprocal of cosine, and cotan, which is the reciprocal of tan, or cosine over sine. I want you to also recall that any point on the unit circle can be represented as cosine theta, sine theta, as you see in this diagram. Any point on the unit circle can be represented as the cosine of the angle and the sine of the angle. Of course, the angle meaning the angle of rotation. Also recall that quadrantal angles are angles with their terminal arm located on the x or y axis. So anywhere that we have a terminal arm located on the x or y axis is called a quadrantal angle. So let's look at finding the trig ratios for these special angles of rotation, which are quadrantal angles. The sine of 90 degrees. The sine of 90, if we rotate 90 degrees, it's right here. The quadrantal angle, in this case, is 90 degrees. The terminal arm is located on the y-axis. Sine, remember, if you look at this thing up right here, sine is represented by the second coordinate, so the sine of 90 is simply 1. Sine of 90 is 1. The cosine of negative 180, I rotate negative 180 degrees. That will be right here. The cosine of negative 180, again, if you look at the coordinates of the point, negative 1, 0. Cosine being the first coordinate, cosine of negative 180 is negative 1. The cosecant of 3 pi over 2, 3 pi over 2 is a positive rotation. This would be 3 pi over 2 right here. It's 1.5 pi. This is pi, this is 2 pi. So this is 1.5 pi, or 3 pi over 2. The cosecant is the reciprocal of sine. So 1 over the sine of 3 pi over 2, the sine of 3 pi over 2 is negative 1. Sine, again, being the second coordinate. So 1 divided by negative 1 is equal to negative 1. The cosecant of 3 pi over 2 is negative 1. The tangent of pi, again, pi is located right here. We're looking for the tangent of pi. Tan is equal to sine of pi over the cosine of pi. The sine of pi is 0. The cosine of pi is negative 1. Again, remember that cosine is the second coordinate. Sorry, sine is the second coordinate, cosine is the first coordinate. So sine over cosine will be 0 over negative 1, which, of course, is 0. The cotangent of negative pi over 2. Cotangent is the reciprocal of tan. So therefore, we have the cosine of negative pi over 2 divided by the sine of negative pi over 2. Negative pi over 2 is right here. Here's the point associated with that. Cosine is 0. Sine is negative 1. 0 divided by negative 1, of course, is 0. The cotangent of negative pi over 2 is cosine over sine, which is 0 over negative 1, which of course is 0. Before we move on, let's have a look at one that's undefined. I haven't got it listed here, but let's have a look at it. If I were to ask you for the, let me think here, the tan of, let's see, tan of pi over 2. The tangent of pi over 2. Tan of pi over 2 would be the sine of pi over 2 over the cosine of pi over 2. I'll have a look at this example because it's a special case here. The sine of pi over 2, if we look at this point, there's pi over 2 right here, isn't it? Sine is 1, cosine is 0. The tan of pi over 2, because 1 divided by 0 is undefined, we say that the tan of pi over 2 is also undefined. So there's an example of one that's actually undefined. So most of these answers for quadrilateral angles will be either 1, -1, 0, or will be undefined. Let's have a look now at finding values of trigonometric functions or ratios for non-special angles. In this case, we have to use the calculator in order to do this. 7 pi over 5 is not a special angle of rotation. Remember that special angles of rotation would be things that have a denominator of pi over 3, or sorry, has a denominator of 3 or 4 or 6, something like that. 7 pi over 5 is not a special angle of rotation. So the only way we can do this one is actually use our calculator. So we got to find the tan of 7 pi over 7 pi over 5. If you have to use your calculator, you need to make sure your calculator is in radian mode first. So most of you have a calculator. You want to make sure that you know how to change it from degree mode to radian mode. I'm going to change mine now and place it in radian mode. And I simply do the tan of 7 pi over 5. I do 7 pi divided by 5, and I get an answer of tan of 7 pi over 5 is equal to 3.07. 3.07. It's the tan of 7 pi over 12. Got to use your calculator for this because it's not a special angle of rotation. B, the cosine of 260. I'll tell you what, before we do B or C, or let's do all the ones in radian measure first, because our calculator's in radian mode, so let's stick with radian mode here. Let's do C next. You're looking for the sine of 4.2 radians. Make sure your calculator's in radian mode, and just hit sine of 4.2. And you should get an answer of negative 0.8716, approximately 0.8716, and it's negative sine of 4.2 radians. We have one more, which is F over here, which is also in radian mode. We're looking for the cotangent of 3 radians. Cotan is equal to cosine over sine. So it's the cosine of 3 over the sine of 3. Again, you do that on your calculator. You'd find the cosine of 3 divided by the sine of 3. And I get an answer of negative 7.015 for the value of cotan 3. Notice that 3 of these were in radian measure, so I kept my calculator in radian mode. Now the other 3 are in degree measure. So we want to change our calculator to degree mode first, which I've now done. And now let's do the other 3. Let's do B, the cosine of 260. Calculator's in degree mode, so we press cosine 260 very simply, and we get negative 0.1736. Let's have a look at E as well, the secant of negative 143 degrees. Secant is 1 over cosine. So you want to do this on your calculator. You can find 2 ways you can do this. You can do 1 divided by that, or you can find the cosine of negative 143 and then press the 1 over x button on your calculator. It doesn't matter how you do that. I'm going to find the cosine of negative 143 degrees. And then I'm going to press the 1 over x button, or x to the minus 1 button on my calculator. There's an x to the minus 1 button there. And now I get an answer of negative 1.252. You want to make sure you're getting these answers. So just check on your calculator and make sure you get the same answers that I have. Sorry, not F. I think the other one that's left here now is D, isn't it? Which is the cosecant of negative 70. Cosecant of negative 70, cosecant is 1 over sine. In the same way as before, I'm going to find the sine of negative 70 first, sine of negative 70. And then I'm going to press the 1 over x button on my, or the x to the minus 1 button on my calculator, and I get an answer of negative 1.064. Negative 1.064. So I think I have all of them done. Let's look A, B, C, D, E, and F. Yes, they're all done. But for these values, because they're not special angles, you have to use your calculator to do them. No way around that. Now, here's an example. Might be a good idea again to pause the recording and try this one before I actually do it. We're looking for the approximate value of the secant of 3 pi over 4 times the tan of 4.2. Now this one does have a special value and a non-special value. This is a special one, so we should be able to figure out what that is as a special value. Then we got to multiply by this non-special angle. Okay, let's do the special one first. The secant of 3 pi over 4, I can do that. Draw a unit circle. A second here, I'll move that around so that looks reasonable. There we go. And we have the secant of 3 pi over 4. This is 4 pi over 4. Whoops, 4 pi over 4. So 3 pi over 4 is one less than that. So it's located approximately here. It's 3 pi over 4. Reference angle, of course, is pi over 4. So if the reference angle is pi over 4, I got to point negative root 2 over 2 and root 2 over 2. Secant, of course, is the reciprocal of cosine. Secant is the reciprocal of cosine. Cosine is negative root 2 over 2, so that gives me a negative 2 over root 2. I need to take that value, and I need to multiply it by the tan of 4.2. So let's do that. That's going to give me, I suppose if we want to multiply numerator and numerator together, we can do that. Let's do that on the calculator. Negative 2 times the tan of 4.2. Now, we want to make sure the calculator's in radian mode first. So I better make sure that mode, let me change my mode back to radians again because it was just in degrees. So let's do that again. Negative 2 times the tan of 4.2 divided by the root of 2. And I get negative 2.51. Correct answer is A. Negative 2.51. Here's another example. Which of these is undefined? Again, you may want to just pause your recording. Try this one first. You see here we're dealing with quadrilateral angles again. So which of these would be undefined? Let's see. Let's label the points again. X is 1, y is 0. X is 0, y is 1. Negative 1, 0. And 0, negative 1. The tan of pi. Tan is sine over cosine. Let's check it out. Sine over cosine will be 0 over negative 1, which is 0. That's not undefined. The secant of negative pi over 2. Negative pi over 2 is right here, rotating in the negative direction. Secant is 1 over cosine. So we got 1 over the cosine of negative pi over 2, which is going to be 1 over. The cosine of negative pi over 2 is 0. 1 divided by 0 is undefined. The answer is B. I don't need to go any further because I know this one is undefined. Okay. Let's have a look at one last example here. Determine the exact value of the secant of pi times the cotan of negative 3 pi over 2 times the cosine of negative pi. Okay. Again, we need to draw a unit circle here to help us out. In fact, I think we need to draw 2 unit circles to complete this one. There's one. And let's draw another one up right here. Move it around here until it's okay. There we go. Okay, so let's use our unit circle. 1, 0, 0, 1, negative 1, 0, 0, negative 1. We're looking for the secant of pi. We know that pi is right here at 180 degrees. Secant is the reciprocal of cosine. Cosine is -1. The reciprocal of -1 is, of course, -1. So the secant of pi is still -1, because it's 1 over -1, which is -1. Divided by, I'll do the cotangent in a minute, the cosine of -pi. There's -pi right there. Cosine is also -1, because again, cosine is the first coordinate. Right? So the cosine of -pi, rotating -pi, cosine is -1. Now let's use our other circle here to find the cotangent of -3 pi over 2. Didn't want to mess up, I didn't want to get it too crowded here, so that's why I drew 2 circles. Let's rotate -3 pi over 2 is here. -1.5 pi. Again, the coordinates of that point is x is 0, y is 1. I'm looking for the cotangent of -3 pi over 2. The cotangent is equal to cotan is going to be cosine over sine. So I got the cosine of -3 pi over 2 divided by the sine of -3 pi over 2. Okay, so the cosine being the first coordinate is 0 over 1, which equals 0. Again, recognizing that cosine is our first coordinate and sine is our second coordinate. Sine is the second coordinate. So we have 0 over 1, which is 0. Okay, let's fill that in. Times 0. So we got -1 times 0, which is 0 over -1. 0 over -1 is equal to 0. The correct answer is C. Finally done. Okay, let's have a look at the key ideas for this lesson. Points that are on the intersection of the terminal arm of theta in standard position at a unit circle can be defined using the trig ratios P of theta, cosine theta, comma sine theta. You can determine approximate values of trig ratios using a calculator in the appropriate mode, radians or degrees. And that is this lesson.